Good morning. Welcome to episode number 58 of the Zoomtown experiment. If you've been following along since the beginning, you know that right now we're going through the last phases of, I think, the second or third complete rewrite of the Zoomie control program. What I'm focusing on right now is verifying that the telemetry information and the ability for the Zoomie to know where it is can be communicated back to the scheduler, and then the scheduler can then update the position of the Zoomie's icon on the virtual layout. And that's right there. So that's the scheduler software. That's the layout that it has. I'll get you a clearer picture of that. What I'll actually do on the other cameras, I will do a video overlay of the video capture straight off of the Raspberry Pi that's recording that, rather than look at a blurry picture in the background. But what we're going to do is take a series of movements, probably stack them together, have it run that course, and we'll make sure that the Zoomie's icon tracks the physical Zoomie. And that's going to require several cameras. In fact, there's one right there above my head, so hopefully I don't knock it down during this filming. But I'm not going to go into, and there's really no need to go into a lot of detail in the code, as much as it is we're going to be working with the trip instructions. So with that, let's just dive right into the code to take a look at our first motion. This will be a test, and it'll perform a cruise motion and a sweeping turn. And what we're going to do, I'm going to provide the initial starting point. This is physically where the Zoomie will start from at both the X and the Y coordinate. Then I will provide a command for it to cruise to the end of that road and then transition into a sweeping turn to go around the curve at the end. And we want to make sure that, of course, the scheduler can track it during that entire motion. So essentially, we're just going to run two motions, a cruise motion followed by a sweeping turn. And all that's happening on several different cameras, so if I get things out of time and out of sequence, I'll do my best to fix them up in editing, because there's a lot going on for filming this particular story. In this view here, you're going to see that motion now. This is about 60 inches right here. The Zoomie will travel along here. There's a QR code right here that will update position. You can ignore that marker. In fact, I can remove that. That was from our previous testing. We'll continue around and stop at that point right there. The front of the Zoomie will be right where my fingernail is. And we'll need to see that happening at the same time on the scheduler's screen. So let's go ahead and run this and see what actually happens. For the most of that motion, it seemed like it behaved pretty good. It might have been off to a slow start. It could have been lagging behind. We'll run it again. And of course, it doesn't know I physically moved it, so we will go ahead, run the program again. It does seem to have a little bit of lag on startup. We'll see how that behavior changes over time. Now I'll try one more. Instead of starting it way back here, I'm just going to drop it in about there. Now it should be off by, let's see, that's 1, 2, 3, 4, 5, about 6 inches or 150 millimeters. Should be off by that relative to what's showing up on the screen. Now it will correct when it gets to the QR code. That looks pretty close. I'm not real happy with that initial lag, but at this point I'm going to push that as a concern off to the background and move on to testing some of the other motions. That lag could be something in MQTT, which I blamed for a few other problems in the past. Turns out it wasn't MQTT. So at this point, I want to learn a little bit more, and then I'll start looking at what I need to fix. For this next test, we're going to perform the check address and return function. We shouldn't see any movement. In fact, the icon should just be off on some random place on the scheduler's layout screen. But when it does go up, check the position, or when it backs up, reads the QR code, it should see where it is and then update the position in the scheduler. So let's see how that behaves. Here's the instructions. We're going to check address. We're going to move back 2.5 inches to do that. We're going to dwell for 1/2 second. We're going to return, moving forward 2.5 inches, and then we'll dwell for another 1/2 second. So let's see how that behaves. And we see that the icon for Zoomie number 3 appeared where it should. Now you'll notice that the positioning is off on the graphics slightly from the real world. And that has to do with right now, when the scheduler positions the Zoomie, the icon, the origin point of that is in the center of that blue rectangle. But my position reference being fed to it is at the location of the sensors, the two photoelectric sensor or photoreflective sensors, the TCR-T5000 sensors at the front of the Zoomie. So I know I'm going to be off positioning a little bit there. I'm going to try to deal with that on the scheduler side so that the Zoomie isn't overburdened with more math to do. So at that point, I think that one was a success. So now we'll move on to one of the other movements. For this next test, we're going to work on the pull-up maneuver. And that will be when we need to go from this location and pull across traffic to start, or in the correct position to make our pivot turn to go along this road. That could be a short version of it or a really long version to get to the far traffic lane. In code, I am going to establish or tell the Zoomie control program where it currently is, and then when it crosses the road, this is the destination it will be at. Now, I have to tell it this information so it has some knowledge of where it is at the start of the move. Typically, this command would follow a previous command that already established its local position or its localization. So we're going to give it the X and Y coordinates of where it is, execute the pup command, pull up, tell it where to go, all that fun stuff, add the instruction. Let's see how it behaves. It really had a lot of lag time on that one. Not sure what's causing that. We'll run it again and see if the behavior's the same. If there's a problem in there, that'll give me something to work with. Again, very, very slow start once it seems to get going, which at that point it's already traveled about 150 millimeters or 6 inches. So this could be a big problem to deal with further down the road. But we are seeing the tracking. That's good. With that, I'm going to move on to the next maneuver. For this next maneuver to test, we're going to work on pivot turn. I've just got the Zoomie located at the end of the road we used in the last experiment, right at that location, and then we'll make a forward pivot turn and a reverse pivot turn. It won't actually show the rotation of the Zoomie through the turn, only the ending position after it gets there. So we'll see on the icon, I'll just go from one spot to the next spot and then hopefully back to where it came from. Here we can see the commands to do that. We're going to establish the starting point so it has some reference on the screen. We will pivot turn right forward. We will dwell, pivot turn right reverse, and then dwell again. Again, we won't see it actually fluidly move through that, but we will see it go to a point and come back. Hopefully I got all the math right and it goes where it's supposed to. We'll run that again. That looked very puzzling and it doesn't appear to be in the right location, so in all likelihood I've probably got some math wrong, but looking at the code here, I think I already see what's going on. So I think I need to change this a little bit. I need to tell it which direction it's facing and it's going to move. And right now that would be south, wouldn't it? And then in the reverse motion it would be going north. So I think that might be what's causing the icon to be in the wrong place. Let's give her a try and see if that fixed anything. Made another mistake on that motion. When it completed the first pivot turn, it started out facing south. So that was the direction we were going. But when we're at that point, we've rotated 90 degrees. So to back up, I'm not going north. It starts out facing east. It starts out moving east. And I'll bet that clears up our issue. Let's give her a go and see what happens. Didn't see enough movement in there. I'm going to run it again. I know it's moving. We see that in where I had the errors. There it is. And then back. Okay, so if I could figure out my own programming language for these motions, things actually work pretty good. So that test looks good. Again, we've got this lag time, but we'll have to deal with that once we understand it in its entirety. Okay, well, we're discovering some lag times, and I thought, while I've got all the equipment set up here, because I'm recording 4 things all at once. I'm recording that, recording the overhead camera, which is right here. That'll see the physical movement. I'm doing screen capture of the Thani software where I'm running the Pico for the Zoomie. And then over on that computer, let's see, that computer right there, which is that guy right there, that yellow thing, that one also has a screen capture on it. So I can see, I can synchronize all the videos and I can see when things are happening. And if I get all the videos synchronized, I can then determine is the lag from the detection of the QR code coming through to the Pico part of the lag, then from the Pico on the Zoomie over to the Raspberry Pi, which is running the Zcheduler software, and then in between there is also the MQTT broker running on another Raspberry Pi. I'm hoping with all of this, I'll be able to detect where the lag is, and then I can work backwards from that. So besides just looking to see if we're getting position tracking, I'm also running another experiment in all this in hopes of finding out what is going on with that lag. But before we go over there, let's look at what I'm going to do. We've checked all the other motions. The last one is to unpark and then park the Zoomie in the driveway. I am providing it with a known starting destination just to have some baseline or base position to work from, some datum. And we're going to unpark by moving back 7.95 inches in reverse, heading in the west direction. We'll have a delay, half a second. We will then park the Zoomie, at which point it should also be reading the QR code and then also updating position. And that'll be in the forward direction, heading east. From your viewpoint on the overhead camera, that's to the right. And then it'll dwell again. Now, again, we probably got lag in there, but at the same time, most important to me is to understand where it is, and then from there, in the coming weeks, hopefully only days, maybe if I'm lucky, I can track that down. So I am getting everything ready here. I want to see the code come up on the shell of the desktop computer. And let's see, we are all set there. We're set there and there. Let's give it a try. It really looks like the delay is, it starts sending data, then there's a hold, and then the data continues again. And that's what I got to try to track down, where that delay is, because I see the Zoomie update on the icon, and then it just stops. Then there's no data coming in over there that I can see, but I can't look in both places at the same time. We're going to run that test one more time, and then we'll call it done for this test. So here we go. Yeah, it's very consistent in that delay. But nonetheless, the tracking is working, the directions and all that, and that was the primary purpose of this test and verification process. Along the way, I discovered that delay. Hadn't seen it before, so something fishy's going on there. But I got a lot more information now for which I can use to dive into and try to understand that problem. So with that, I'm going to wrap up this video. I'm going to call it a success. Tracking is working, telemetry is working, but I got to fix it, make it better, and that's okay. In our next video, hopefully what we're going to be doing is, instead of running tests from the Thani editor, sending it directly into the Pico program, the trip instructions, hopefully we'll be back over at the scheduler sending data in, and then we can start testing actually routes and things of that nature. So till then, thanks for watching, and I look forward to seeing you in the next video.